Welcome to Gas Stoichiometry Tutorial Videos, Section 7.3 from the textbook. When we're taking a look at any stoichiometric problem, gas or otherwise, the first thing we're going to do is write the balanced chemical equation and list any given measurements we have within the problem. We will then convert that measured or given quantity into moles as the second thing. Third thing, we will calculate the moles of the required substance using our mole-to-mole ratio from the balanced chemical equation. And then we will convert the moles of the required chemical species into the final quantity that has been requested. So, taking a look at this, we start with our measured or given quantities and we'll turn it into moles. We use the mole-to-mole ratio given from the balanced chemical equation, and we will use our turn that into whatever is given. Now, with solids or liquids, we're using mass. With gases, volume, temperature, and pressure in both cases. A couple of reminders: molar volume, it's the same for all gases, so if we're at STP or SATP, we can use the molar conversion of 22.4 liters per mole or 24.8 liters per mole. This is only if we are at STP or SATP. As we take a look, we also need to remember that anything dealing with gases has to be done in Kelvin. So all things in Celsius will need to be turned into Kelvin by adding 273. And if we need to convert back to Celsius at the end, we will subtract the 273. So let's take a look at a couple of examples. First thing, 300 grams of propane are burned in a barbecue. What volume of oxygen measured at SATP is required for the reaction? We will first of all remember that we are at SATP, so we can use molar volumes. We start off with the balanced chemical equation, and here we've got 300 grams of propane, and we're also calculated here the molar mass of 44.11 grams per mole. We then convert that into moles using our molar mass ratio. We then use our mole-to-mole ratio of 5 to 1 in order to find that we in fact are using 34 moles of oxygen. Now, each one of those moles uses 24.8 liters, and so that comes to a total of 843 liters of oxygen that will need to be consumed. Second example here, we've got what volume of ammonia at 450 kilopascals and 80 degrees Celsius can be from reacting 7.5 kilograms of hydrogen with nitrogen. Now, we are not at STP or SATP. We cannot use molar volume in this case. We will use the ideal gas law, but the procedure is basically the same. We start off with our balanced chemical equation. We've got 7,500 grams of hydrogen, molar mass of 2.02 grams per mole, and we're looking for the volume of the ammonia, pressure and temperature given. We're going to take the mass of hydrogen given and find the number of moles, 3,713 moles. Using 2 to 3 ratio, we're looking for ammonia. We have hydrogen. We find that we are going to produce 2,475 moles of ammonia. And then we're going to convert this into volume using the ideal gas law. Plugging in our numbers, remembering that R is 8.314, given the moles that we calculated previously, temperature and pressure that were given to us, we find that we have 16,150 liters of ammonia, or to two significant digits based on the question, 1.6 times 10 to the 4 liters of ammonia.